So, welcome. Hopefully on Monday early, you received email about an independent assignment to complete your first attempt of the Module 4 assessment. And then after you completed the first attempt of the Module 4 assessment, to progress on to Module 5 to engage the 5.1 assignment. So that both of those would be in place and ready today. Some of you were finishing up with the assessment as the class started today, and not everyone has engaged the Module 5 assignment, the 5.1. So I've gone ahead and extended the deadline on that until Friday, 10 a.m. so that you have a chance to complete the assignment in Module 5. The first assignment is 5.1. And even though it states the deadline is 10 a.m. this morning, as a part of that independent assignment Monday, essentially you have until the start of class on Friday, 10 a.m. to finish. There will be a 5.2 assignment and the solution posted by that time. So what we'll do is post the 5.2 assignment and the solution. And then after our item analysis of the Module 4 assessment, your first attempt, we're going to post the reconciliation and then the retake. And it would be good if you could complete the retake and the reconciliation, not necessarily in that order, by the time we start the Thanksgiving break next Wednesday. So next Wednesday we will have class, but then we'll be off Thursday and Friday of next week for Thanksgiving. There is a full week of classes after Thanksgiving before final exams. So that is one aspect of our calendar this year, kind of like the leap year. Every 4 years, there's an extra day in February. This is the same kind of thing that happens with the calendar. Ordinarily at UVI, when you finish Thanksgiving, the following week is most often final exams. But because Thanksgiving falls earlier in the month this year, there's a full week of classes after Thanksgiving for our 6th module. And then we have exams the first full week of December. So that's just something we wanted to share with everyone. Are there any questions about timeline, about assignment expectations, and that kind of thing? Can everyone see the screen?
Yes.
Okay. What you're seeing is the item analysis of the first attempt of the Module 4 assessment. Today is the 15th of November, and we'll go ahead and just print a copy of this for record, so we know what to change up in our, change up in our retake. If everybody got certain items correct, we'll probably eliminate those. So we're starting to do more of that now in our final modules. If everyone answered correctly, we'll probably eliminate those answer choices and put some fresh material in there. In Module 4. So let's look at the class average. Class average was flawless. If you take this on a 5-point scale, it means that students who engage the assessment scored an average of 75% with their first attempt. That's a C, a middle C, 75, right? Took 25 minutes out of the potential 60 minutes. So we have students that are still rushing a bit. Maybe the schedule was jammed up and couldn't do the assessment until this morning, so we were in a hurry. That might be a factor here. I have changed the notifications for Blackboard, and I want everyone to be aware of this. I have changed the notifications in Blackboard as we're getting down to the wire. I would like very much to automate notifications so that they start hitting your cell phones and your personal email addresses in addition to your UVI email account. If that proves to be a nuisance for you, please give me a heads up, but I've added some extra stuff in the system so that you'll start getting hits on your personal email, and in some cases, your cell phones and text messages for reminders. We don't want people to miss deadlines needlessly. That said, from now until we finish our last week of classes after Thanksgiving, so we have today, Friday, and 2 class days next week, we'll have a full week of classes after Thanksgiving, and then finals week. Since we're in the final stretch, you're going to see that deadlines are a bit shorter and the notices are going to come more frequently. And that's just to make sure that people are getting a chance to resubmit or reconcile previous submissions that have been scored, right? And we do have a lighter set of assignments and solutions for the last 2 modules, but we do have assignment and solution for each of the 2 remaining modules, the last one being special topics. So without further ado, let's review the items that pose the greatest challenge for students in this module assessment. The algorithm scored 9 medium questions and 2 hard. There was a good mix of easy, medium, and hard. There were only a few where students either got every answer incorrect and answered the same way, or the answer is correct completely and answered the same way. That's why we have 5 of those questions are designated cannot calculate or considered poor questions. The first item is multiple choice, and it reads, diode resistor circuits are used to create the physical versions of many different logic gates. Which of the following logic gates is not a common example of this legacy method? And in the study guide addendum or on the websites, the NOR logic gate is the correct answer. So, any questions about this item? Now, I just want to mention this. Resistors have a tendency to block the flow of electricity. And we said that knots were like wildcards and they would flip the results. So actually, NOR is a correct answer, good answer. The knot would be one of those logic gates that, since it's flipping the output, having a resistor in the mix, it's about physics and material science, but that is a thing. Let's look at the next question, multiple choice. It says, this interface view of a digital component shows a small triangular shaped inset or indentation along the side of a simple diagram. So you could flip this diagram where this rectangle would be horizontal instead of vertical, and the triangular inset would appear on the bottom. It says this means that this digital component includes, that's the telltale sign, right? That inset, a sequence capability, right? What is this logic gate? When you see that triangular chunk out of there, what are we talking about here? Which logic? Go ahead.
The mux.
Actually, the mux would have a switch, but it's I'll give you a hint. DFF.
The data flip-flop.
Yes. So when you see that triangle, think of that. Everybody knows what an old-timey clock face looks like, right? You have the 12 numbers around the dial, and we're so used to digital time now, it's like mind-blowing that some of our younger people now, they don't know how to read a regular clock face. That's a thing now. They're having to teach it in school because everybody's used to using smartphones and digital watches and such, right? But there's a hand, and oftentimes the hands of a clock have like an arrow, a point on the end. So just remember that this is like the hand of a clock with a point on that dial face. If that helps, help you remember that it has to do with time. The whole idea of being able to sequence instructions in a computer, this is a critical dependency, and it's huge. So just remember that if you have this in the mix, this is a logic gate that can handle sequence, right? Or timing. And it's also a component of the system clock, right? So the rest of these are bogus answers. There was a diagram about a built-in digital amplifier, and maybe the amplifier had a DFF in there. But that's not the point about this particular diagram, right? Any questions about this? Moving right along. This was a true false, I believe, probably an extra credit item. The graphic shown below of image D represents one of the very first transistors made of NPN compounds. Is that true or false? It is false. This image represents a vacuum tube. It's glass and metal, and there's a vacuum in there, and it's one of the first switches, but that predates transistors. When computers were made out of vacuum tubes, the smartphone that you hold in your hand right now would fill an entire 4-story building of nothing but vacuum tubes. It would draw enough current to black out Frederiksted or Christiansted or Charlotte Amalie, and the heat would be a problem because this thing glows, right? Now, vacuum tubes are becoming a thing for musicians because there are older amplifiers that have a warmer sound, like a richer sound, and it's because this is considered to be like an analog component, like record players, or this is like, thing to remember is that this predates transistors. This is what went into the first radios back in the 1920s and 30s, when radios first appeared on the scene before they had electronic components, before they had transistors, right? So just want to make sure I'm surprised that as many students fell for that. That's just kind of maybe I didn't spend enough time on that in class, but any questions so far? Any comments? Can anyone unmute your microphone so we know we've got everybody here?
No.
Okay. All right. So the next item was a multiple choice question. Which color of element is used for the physical materials in modern digital components? Modern digital components are made out of semiconductors. The metals would be conductors. The non-metals would be non-conductors. They would be insulators, right? And it's the semi-metals. So it's this yellowish, orangish, goldish. I mean, that's orange basically, but it's a gold color. The other color that most students answered was blue. This digital components are made out of semiconductors, and the semiconductors are connected together with metal wires or traces on the chip. It's called a trace. I guess we could have another question in the final attempt that reads, which color of element is used to connect modern digital components to build circuits between the semiconductors, right? And in that case, it would be blue. Does that help clarify what's going on here? Is that a better way to state that? We could have a question for your final attempt that reads, which color of element is used for the physical materials to interconnect modern digital components? And the digital components, or digital components are composed of multiple logic gates, right? So we use the term digital components to talk about combinations of logic gates. So whenever we're talking about combinations of logic gates, we're talking about the physical equivalents of transistors, right? And together they are used to build the digital components. So all of that logic conductors are semiconductors. Logic gates are semiconductors, right? And if you combine logic gates, then you have digital components. And then when you get to all the different kinds of digital components, now you can build a whole computer system. So that's where we are. That'll become much more obvious in our next module, I think. If there was any confusion over that point. I need each of you to not be shy or hesitate if you have a question or a comment or an observation about an item. If you think that an item was worded in a confusing manner, or if you know that the answer choice is just plain incorrect, I'm counting on each of you to unmute or raise a hand or something, okay? Is everybody still with me?
Yeah.
Great, thank you. Multiple choice, identify this logic. One of the things we said in class was you needed to memorize the logic statement difference between, right, DFF and, you have a memory register and then we have a DFF. The logic statements are distinctly different. One thing to remember about the memory register is that what comes out of the memory register is the same thing that came out 1 second or 1 clock tick, 1 cycle, 1 hertz, 1 system cycle before. So the T-1, T represents not just a second, but if you had a 10 hertz computer, there would be 10 cycles per second. That would be the previous cycle, the 10th of a second before. It's the same thing that came out before. So this, just remember that what comes out now is what came out before, right? That's the very definition of what a memory register does. If you store a 1 in there, what comes out now is the 1 that came out the cycle before. If you store a 0 in a memory register, what comes out now is the same 0 that came out a 10th of a second before, or a 100th of a second, a millionth of a second, a billionth of a second before. So T doesn't represent whole seconds, it represents clock cycles. Hope that helps. Questions? Alrighty then. PCB. So a printed circuit board, right? According to your study guide and related sources, what physical material is used to coat or plate a printed circuit board during the manufacturing process? If you're printing a circuit, it is laying down a thin layer of copper, like literally like a printer. So you have multiple layers of this printed circuit board, and there can be circuits embedded inside this thing. And you'll often see that if you look at the edge of a PCB, you'll notice hints of copper trace, right? So it's copper. Gold was used a long time ago in telephones and on phone connections and that kind of thing, and originally plated on computer components to reduce the resistance to flow. Gold is one of the best conductors of them all, and that's why there was thin gold plating on a lot of the metal. But that's not the primary thing. They don't put that inside the printed circuit board, because if they did, a printed circuit board would cost thousands of dollars, right? Tin is used for solder. Aluminum is used, well, not really used. Any questions?
No, sir.
True, false question reads, transistor logic or TTL chips are made of components that require 5 volts of power to run the diodes and resistors used to compose logic gates, while the newer CMOS designs require less voltage. That is a true statement. So in our final version of the Module 4 assessment, you can probably expect a different question. It might say, hey, the older CMOS designs, well, that would be false because CMOS came after TTL. So before you had transistors, you had vacuum tubes. Then we had transistors. Then the transistors were miniaturized until we could put them on a single chip, a TTL chip. And as we shrank them even more, we were able to do field effect, right? So that's what that MOS is about. It's about circuit field effects on a smaller level. And that means you can shrink the logic gates down even further. That's where the new technology takes much less than 5 volts, which means that the computer is much more efficient and the batteries last longer. And if you think about it, that all makes sense. So now we're working with a volt or 2 at the most, compared to 5 volts. Huge difference. That's one reason why batteries, you don't need a D-cell battery to power a you would use a much larger battery to power a transistor TTL chip radio, the radio that your grandparents had. And the reason you'd have to use a regular battery and it would only go so long is because it required 5 volts. All right, moving right along. So this multiple answer question was a significant challenge. This was worth quite a bit more. And from the average score, it looks like that was pretty bad. We'll run down to this question and then we'll skip down to the bottom to the remaining ones. Yeah, this particular. Let's see. This multiple choice question represents the behavior of which digital component? So digital flip-flop is, it's gonna flip and flop values kind of like the tick-tock of a clock. Maybe that's another way of, it's a very crude way of explaining it, but I hope that helps. So flip-flop is like a tick-tock, right? So a digital flip-flop, it's gonna alternate values, and that's where the sequence comes in. It works like the metronome. It helps you track cycles, right? The logic statement is going to work different. And so this is the logic statement that's distinct for a DFF. That's in your study guide. Any questions about that? So what goes into a digital flip-flop, the cycle before, the important thing to remember is that the value that's going in the cycle before is different than the value coming out. MOSFET. So nearly everyone got this one correct, but let's just make sure we understand here that this is a true answer for the true-false question. CMOS digital components use field effect transistors, or FET, right? MOSFET. CMOS. The term FET is part of that innovation, which I find very apropos. Most folks in the U.S. Virgin Islands are very familiar with the term FET. It's just a different context altogether. But field effect transistors, as advances kept progressing, they were able to create P-channel and N-channel components. PNP were like different kinds of transistors, right? So, yes. Moving right along. This multiple choice, these next three multiple choice, nearly everyone answered correctly. Same with this true false. Everyone answered these questions correctly. That's why we couldn't calculate. It's this final multiple answer that is posing a challenge for students. The multiple answer question reads, a computer architecture student is having difficulty analyzing the logical behavior of the complex logic gate shown in image C. See below. Select the following observations about this diagram that are appropriate or correct. And one of the things that's important about this image is that this OR is circled in green and this wire is pointed to in red. So it says the green logic gate receives inputs from B and C. Well, if we take the green logic gate and we trace this back, it forks from B and the bottom input is from C. So that is a correct statement. I'd select that. The red wire supplies input for a final OR gate. So this red wire does provide one of the inputs for the final OR gate. That's an OR. It says proper labeling of gates and wires would help reduce errors. That is a correct statement. In this diagram, we don't have differentiations between 3 ands and 2 ors. And if we're not careful, those blank spaces can come back to haunt you. The wires are also true. We have a W1 here, a W2, and a W3, and a W4. So that would help avoid mistakes tremendously. The two options, the one option that threw people, it said, the red wire delivers input for a final AND gate. This is the shape of an AND right here. This is the shape of an OR. So this is the output of the and, not the input. This reads input. If this answer choice were changed and it said the red wire delivers output from a final AND gate, that would be correct. This is the output of this and it's the last and in the sequence, right? So we have 1, 2, 3. This is the third and, last and. Any questions about this?
No, sir.
Okay, there is one thing I would like to share with you out of Module 5 in references. I do want you to get started as soon as possible. CPU types build your own, the next assignment. You're going to get a chance to build your own computer. I'm going to give you a budget. We're going to pretend it's Christmas time and Santa Claus has just brought you $1,000. And you get to build your own CPU. The other thing I'd like you to do between now and Friday, I want you to pay close attention to the first part of the Module 5 study guide. In particular, this section right here. Now, we have mentioned the von Neumann diagram for computer architecture. John von Neumann was a pioneer. He received an award that's not unlike the Nobel Prize for Computer Science. And John von Neumann's model for how computers and computerized devices has remained true for the last half a century and longer, right? The main components of every computer system or computerized device that you know and use have the same basic components organized in this manner. And what I want you to understand is that this input-output is deceptive, but that input-output concerns all of the peripherals, including the hard disk. So the most important thing I want you to understand is that in this diagram where you see input and output, a hard disk is a data storage device where it provides input to the processor and it receives output from the processor. We call that reads and writes. Those reads and writes are persistent memory. It's a way of storing the data and the instructions once the power is off. If you don't have that hard disk, you don't have startup instructions the CPU can execute to even load the computer to turn it on. It's not apparent when you look at input and output. Input is also keyboards and mice. Output is also displays and sound. Input and output together can also be network interfaces, Bluetooth interfaces. Output can be printers, right? So you could be printing something. So in some cases, devices are one direction only. There are special devices that are both input and output. And without those, we wouldn't have a computer. If we couldn't connect it to anything else, it would basically be pretty limited in what it could do. If it couldn't store information on the hard disk, there you go. We'll talk more about the CPU and memory as we begin our class on Friday. Please be sure to reconcile your first attempt to the module for assessment and then engage the retake of the module for assessment as soon as it posts, so that that's out of the way before we break for Thanksgiving. Are there any questions about this diagram or what's coming next before we clear today?
Not really, but is there a date for the final exam?
Is there a date for the final exam? That's a very good question. There is an exam schedule on the website, and we will be following the final exam schedule for the first week of December. But I will tell you this, your final exam will be 2 hours long. It will involve questions from all 6 modules. I'm not gonna have this in person. You don't have to sit in a room and watch me stare at you for 2 hours. Once the final exam schedule says, okay, CSC 241, and it could be like a Wednesday. We'll look it up in just a second, but you don't have to sit for the exam at that time. You have through the end of the week, 11:59 p.m. Saturday, to complete the final exam. So even though the final exam is available and you can engage it according to the official UVI schedule, if you want to spend more time studying and resubmitting and getting a higher points logged before you go into the final exam, you can do that. You just have to have it finished by 11:59 p.m. Saturday, December 9th at the latest. Once you start the exam, you can't stop it. So that 2-hour window, the clock is ticking. You can't stop, you can't pause it, you can't do anything except finish it. So, but if you have other exams and you need to plan your week and you need to follow the exam schedule, it will be available per the official exam schedule. And let's find out what that is now. Okay. UVI. So we'll answer that question. I'm glad you asked that. And you're actually the first person to ask that, which is really cool. Start rather says, so with the calendar, maybe it's got a link on the calendar page. Final exams are from the 4th to the 9th. That's why Saturday is included, right? Let's see if we can search. Let's see if we can search for final exam schedule. It's usually out here. No, may not be out yet. I'll see if I can inquire of someone in academic affairs about the exam schedule. Does anyone else familiar? Does anyone else have a copy of the final exams yet? No? Okay.
Actually.
All right, we'll run that down for you and we'll publish the information promptly. Thanks again for asking. Any other questions before we clear?